Okay, 50E is one of the questions you said you needed help on. And so what reaction that's going on here is the Wittig reaction. So I'm going to do a quick review of the Wittig reaction before I get into the solution for 50B. So basically what this is the reaction of any carbonyl-containing compound and a phosphonium ylide. And so the reaction isn't that hard. Basically what you can think is just the double bond of this phosphonium ylide is sort of just going to replace the carbonyl double bond. And so whatever is attached over here on the phosphonium ylide is now just going to be attached to these carbons of the carbonyl containing compound. So let me draw out the product and number it so you can see. So we have these carbons from the ketone, and then basically instead of having an oxygen over here, we now just have the carbon of the phosphonium ylide. So I'll label that, just these two carbons here are there. And so I guess when you're trying to visualize this in your head, just think sort of cut this oxygen off and then just sort of place this whole double bond right in its spot. And then the important thing is to always just to count your carbons, make sure that you've accounted for all of the carbons in your reactants and that they're all in the product. And then similarly, working backwards, you can think if you're seeing this double bond of the product over here, and you're trying to think, where did that come from? Basically, all you have to do is just think, okay, I'm going to sort of break this off here and just put the oxygen back in. So let's look at actually what's going on in 50E. They're asking you to start with bromocyclohexane and get to this. And so you can see in this product, this sort of looks like what we just went through. We're seeing there's a double bond and just carbons attached to it. And so if you ever see that, that's potentially something that could have been produced through the Wittig reaction. I'll label this up here, phosphonium ylide. And so basically what the book solution is going through is you have to sort of produce this phosphonium ylide, and you do that by starting with an alkyl halide, and that's what we have here. We have bromocyclohexane. And so these are the steps that are going to produce the phosphonium ylide that then can react with the ketone or carbonyl containing compound and produce the double bond. So here, this is just replacing the bromine. This is positively charged because in this stage here, it's neutral, it's gaining another bond to this carbon right here, now it's positively charged. And if you want to visualize this, this has 2 electrons right here, and it's basically going to do a substitution reaction and kick out that bromine. There's one more step, you have to add butyl lithium, 1, 2, 3, 4, butyl lithium. That's going to so now we have the phosphonium ylide here, which is what we started with in the example that I gave you above. I just didn't show you how to produce it. So these steps that I've drawn so far are just how to produce your phosphonium ylide, and then we have one more step. We need to add some carbonyl containing compound that the phosphonium ylide can react with. And so when you're trying to visualize that, let's just count our carbons here. Let's see how many carbons we need. So you can see what's similar between what we need to get to and what we already have. So basically what we're dealing with is we just want the carbonyl compound to contain this right here. And so if we simply just add in this 3-carbon ketone, that's what you're going to get. because you can think, remember I said just think about this double bond just completely sort of taking over the place of this double bond. And so you're basically going to have this carbon now making a bond to this carbon, and this carbon. And that's what you have shown in the product.